You know, every so often, a technology that was supposed to be a decade away just has its iPhone moment. Well, that just happened with quantum computing. The timeline we all thought we knew, it has completely, and I mean completely, collapsed. Over the next few minutes, I'm going to show you exactly how this happened, and more importantly, why it's about to change literally everything for business.
Look, this isn't just hype. This single sentence right here, it captures a massive shift that's happened almost overnight. That future we were all told was way off on the distant horizon, well, it's here, and the barriers are just falling away one by one.
And we have a date. Seriously, this isn't some vague, far-off prediction. IBM has publicly put a stake in the ground, 2026. And think about that for a second. That's not a decade from now. That is a hard deadline, and it is coming up fast.
And to be clear, this is not going to be some lab trick or a carefully picked benchmark. No, we are talking about a meaningful, real-world problem where a quantum computer will officially, definitively outperform even our most powerful supercomputers. The era of what they call quantum advantage is about to begin.
So, the big question is, how did we get here so fast? Well, it turns out a whole series of fundamental breakthroughs have just slammed the accelerator on the entire field. And I'm about to walk you through the 3 biggest ones that made all of this possible.
In fact, you're not going to believe this, but in just the last 90 days, we've seen 3 giant leaps forward. Each one on its own is a total game changer, but together, they solve the core challenges that have been holding us back from building a useful quantum computer. So let's dive into the first one.
Okay, first up, a company called D-Wave. They tackled the biggest physical roadblock to making quantum computers commercially viable: scale. See, the old way, adding more quantum bits, or qubits, meant the entire machine around them, all the wiring, the cooling, had to grow exponentially. It was a total nightmare.
But D-Wave just demonstrated something called on-chip cryogenic control. Now, what does that mean in simple terms? It means they figured out how to control way more quantum power with far, far fewer resources. This is just a massive step towards making these machines practical and affordable, not just some wild theory.
And this isn't just some small, incremental improvement. It's a huge leap. It's the quantum equivalent of going from those old, room-sized mainframe computers to the laptop you're probably watching this on right now. It happens so fast. You can think of this as them solving the packaging problem.
All right, on to the second breakthrough. This one tackles the reliability problem. A team at Spain's National Research Council went right after the Achilles heel of all quantum computers: noise. You see, quantum states are incredibly fragile. Any little disturbance can wreck the whole calculation.
What they did was successfully demonstrate something called Majorana qubits. And the key thing here, the part you really need to remember, is that these special qubits are naturally resistant to errors. They store information in a way that's just inherently more robust and stable than any design that's come before.
And they proved it by achieving what's called millisecond scale coherence. Okay, think of it like this. It's like a spinning top that can now stay perfectly balanced long enough for you to actually perform a complex trick. For a quantum computer, that window of time is everything. It's the time it needs to solve a problem before the quantum state collapses. And finally, the third giant leap. This comes from a collaboration between Fermilab and MIT Lincoln. And if the first 2 breakthroughs solved packaging and reliability, this one gives us a brand new blueprint for building at a massive scale.
This new approach is called trapped ion computing. Now, the technical details are super complex, but the takeaway for us is actually pretty simple. This new design could potentially let us build systems with millions of qubits, a number that, until just a few months ago, was basically science fiction.
So, let's just recap. We have 3 massive hardware breakthroughs: a way to make them practical, a way to make them reliable, and a blueprint to make them huge. But here's where it all comes together. Here's where we connect the dots to something that affects every single business today: AI.
So, what on earth does a more efficient, stable, and scalable quantum computer actually have to do with the AI tools we're all starting to use? The answer? Everything. The convergence of these 2 fields is creating an entirely new kind of intelligence.
You see, classical AI, for all its power, it just hits a wall when it faces massive optimization problems. We're talking scenarios with millions of variables that all depend on each other. But quantum-assisted AI, it's built from the ground up to absolutely crush exactly these kinds of challenges. It's not just a faster AI, it's a fundamentally different way of solving problems.
And this isn't some academic exercise, right? This new capability unlocks the solutions to some of the biggest, most valuable challenges in the entire world. We're talking about problems that are currently unsolvable, with, yes, trillion-dollar implications.
And the roadmap is actually pretty clear. Microsoft frames it perfectly. Right now, today, we are at level 1. We have these noisy, experimental machines. But that 2026 date, that marks the arrival of level 2. Reliable, error-corrected machines that can solve real problems for real paying customers.
And when we talk about solving real problems, yeah, we're talking about serious money. That jump to level 2 capability is projected to create an absolutely enormous amount of value, and it's going to happen fast.
And get this $150 billion figure, that's not the total market for quantum computing, not even close. That's the projected value just for its application to machine learning. It's a massive slice of an even bigger pie.
So what kinds of problems are we talking about? Well, imagine optimizing a global supply chain in real time to deal with disruptions. Imagine discovering new life-saving drugs by modeling molecules in a way that's impossible today, or creating financial models that can actually price complex risk. These are the grand challenges quantum AI is built for.
So, what does this all mean for you, right now? It means a very familiar pattern is about to repeat itself. And the people who recognize it first are going to gain a massive, maybe even an insurmountable advantage.
I mean, just think about the AI boom we're living through. It started in research labs, then it moved into specialized enterprise tools, and now, boom, it's everywhere. The exact same pattern is happening with quantum computing, and we are right at that crucial transition point, moving from the lab into real enterprise tools, right now.
The quantum era isn't a decade away. It's here. And just like with AI, the first movers, the ones who get it, who understand it and start building around it before their competitors even know it's happening, they're the ones who will win. The question isn't if this is going to happen. It's already happening. The only real question left is, will you be positioned to win?